Okay, get started at 35 minutes after the hour. Give some stragglers a chance to get in if they just saw the reminders that went out on Facebook and via the email announcement list. And I'll be including more of that information on the opening screen. So for now, I will be on mute while I finish a few things up and we'll get started. All right, here we go. Welcome. Appropriate salutations for your time zone. My name is Mark, KA6WKE, and I live just outside of San Diego. And today we are going to be continuing to build the control boards for a desktop kilowatt amplifier that I'm building. That's based around a pair of 4CX 250B Tetrode tubes, and they look like this. Oops, what's happening here? There we go. Now you guys can tell what's going on. They look, size of my thumb, just like that. Pretty cool looking little tubes. And before we get going, though, I do have an announcement that in December, the third Saturday of December, which I cannot remember the date off the top of my head. I don't know why I didn't look it up. I'm going to be doing a live stream on how to get started building kits. And this is for the person that wants to learn electronics assembly but has never done it before. We'll cover topics such as safety, the types of tools you'll need. We'll talk about soldering, how to solder, how to fix your mistakes, because that happens. Different types of solders, fluxes, other chemicals that are used to work on your board or on your project, and we'll build one. We will build this little audio amplifier kit that I got from Electronics Goldmine, and I'll put all the links and things in the description below after YouTube's finished rendering. And this general purpose amplifier, I chose it because it has a lot of through-hole components of all different kinds, including capacitors, electrolytics, so other ICE and integrated circuit and things like that. Even comes with a speaker and a nice little board. And we'll go through this kit and assemble it. So I will be putting a page together up on the website at ka6wke.net here this week to with all the tools, links to various recommendations for tools, soldering station or a soldering pencil, everything you need to get started, and we can build this together online. So with that said, I got all the parts last Saturday, and I went through a bunch of them. It was about the size of a football worth of parts. And the way I order mainly through DigiKey, and the way they ship things is everything's tossed into just one big bag. So you have to go through and start organizing your parts. And what I do is I start with, my habits is to start with resistors, for example. Now, I didn't buy resistors through DigiKey. They are I just can't stomach paying 54 cents for a resistor. So I went to my local Fry's, and they have bulk kits of resistors like this for like $8. 610 resistors of all different values. You can see there. So 27R, which stands for, the R stands for resistance, means 27 ohms. And then you move along, you'll see 1K0, that's 1,000 ohms or 1 kilo ohms. So the K represents the decimal point. And then even in mega ohms, right here is 1 meg quarter watt resistor. There probably is a 1 giga ohm or better. I've never used one or seen one in the wild, but I'm sure it exists. So what I did last night was I went through, and all the resistors are color coded with these little bands, as you can see under Mark's scope over there, that on the left. So that's actually a 1/8 watt resistor. It just kind of looks huge because of the magnification. And I'll be using that a lot through the stream, so I can show you the different parts and values and things. So what I do is I just sit in my easy chair and dump these out on the table next to the chair, and I just start going through the color codes and write down what they are. And then I put them all in order so I can find them quickly. You don't want to really have a pile of things on your bench, and then, yeah, I got to find a 1K resistor and you have 610 to go through. So that's not very efficient. So spending a little time organizing your project will help a lot. Now the rest of the components, there are other high wattage resistors that came. One is, let's see if I can find it here. One is 50 watt, a 1 kilo ohm 50 watt resistor. It's about the size of a small cigar. And going through the different capacitors, and then a lot of the discrete components are in these aluminized anti-static packaging, which I don't know if it really protects the part. It might be an interesting test. And so I just organized those just by the fact that they're all in there in this area of the parts bin. And this little bin is just from I think the dollar store is where I got it, or Container Store or something like that, to hold things up. So here's the board we're going to be working on today. And this is more of an advanced project because it doesn't come with any assembly instructions. So how do you handle a kit or a kit of parts that do not have assembly instructions? Well, there's two ways to build kits that don't have assembly instruction. I gotta get clean. I didn't pull this IC out of here. And one way is start with the components that are the lowest to the circuit board, and typically that'll be your resistors. Your standard 1/4 watt resistors can lay on the board flush. We'll put this op amp right back into here, into this. All right. Can lay right on the board, and then you build it by layers. So then you go to the next height of parts. So resistors would be flush on the board, and then say you go to a capacitor, and that's going to be a little taller, and then electrolytics would be a little taller, and you build it up that way. It's easier to do in that fashion because once the tall parts are in, it can limit access to the board. Now this is a single-sided through-hole board, so it's not so much the room that's needed, but sometimes for doing repairs and things, it can be beneficial to stack build your project. Let's see. The other approach I like to do is to follow the power supply. So I'll start with the inputs. For example, up here is the 12 volt in, 12 volt, and then follow the schematic and insert the parts needed to build up the power supply portion of the board. That way, once the power supply part is built, you can test it, and if the power supply is good, then you can start building other sections of your board based on the schematic, or following the stacked build portion of it. This becomes building in a stacked fashion is very beneficial approach, or a good technique to use when you're working on surface mount. And I do have a surface mount project that we will probably do the first Saturday of January. and it's an antenna analyzer built around an STM32 microprocessor and all that. So it looks pretty cool, and we'll build that too. And I will also plan on an episode on how to build surface mount projects. It's not as hard as you may think. Okay, so I got these boards. There's two of them. We're only going to work on one today, and we're not going to be able to finish the board today, and that's due to the weather here in Southern California. I'm far south of the fires that are up in Central and Northern Californias, but we're in a weather pattern that's called Santa Ana condition, and that's where the winds come from the east over the desert instead of off the ocean, which typically gives us the better notice my camera's not working here. Hold on. I think what happens with my scope is when I put the machine, so I get all ready the night before, and I think it, oh, I didn't want to do it that way. All right, Schoonover, how are you going to dig yourself out of this one? Nope, that's not it. Okay, hold on. Technical difficulties. What is going on? Aha, there's my oh, we don't want that. Let's just delete it. Yes. Okay, I see what I did wrong. Okay, let me re-add it. I accidentally told it to display the screen instead of, no, I don't want to display capture. I want video capture device. There we go, you rocket scientist. Okay, still getting familiar with the open source broadcast software and things like that. Oh, that's much better. So now, do a little adjustment here to get everything in. Okay, that's better. So this Santa Ana weather pattern generates very low humidity. Like, I think it was 12% yesterday. So anywhere you walked around, you were you were getting sparks, static electricity flying. So even though my workstation is, and my soldering station and all that is ESD safe, I'm not going to risk any of the discrete components. Discrete components are like transistors and things like that, or any of the integrated circuits. I will wait until the weather's a little better. So see, there are times in Southern California where, weather can impact what you want to do. It's just very rare. So got these boards from Ian, G3SEK in the UK. He's sold thousands of these. These are control boards for Tetrodes, and he has things for Triode tubes as well. And they do a lot of the control functions, bias circuitry, ALC, other voltages that are required for protecting the life of a tube. And I went this route instead of following a schematic or something on the internet. I thought these were really slick, real slick solution, and took a more, since this is my first amplifier, I decided it would be a better approach for success. And they're real high quality boards. They're all fully silk screened on top, and they are tinned on the other side, on the circuit side, and or trace side of your board. But you can see I haven't cleaned it yet. It's got stuff from tape on it and my fingerprints as I rub all over the place. So you need to clean your board and have it very clean, no oils or anything on it. And there are two solutions you can use to clean them. The first one, which I do not recommend you use, is acetone. It's an effective cleaner, but if you get it on the silkscreen side of the board, it will erase everything. It will dissolve all this nice printing, and then your project just got a whole lot more difficult. So avoid the use of acetone. Even if you're indoors and you want to use acetone, you just have to take it outside because it can build up fumes pretty quickly. So what I use instead of acetone is I bought a gallon off eBay of 100% isopropyl alcohol. Now, if you're wondering why it's 100%, that means it has no water in it. And you want to make sure you keep the lid tight in that. I put it in a second container, a smaller container, for the alcohol. And the reason why you can't use, or at least you should not use, well, I'd say can't. Don't use the alcohol you buy at your pharmacy or your grocery store. Even if it's 99%, that means it also contains 1% water. And when you wipe that on your board, it'll clean your board, but then you might end up with these white streaks, and that's from the water. So don't use it. I think it was $20 for that gallon, and I've had it for 2 years now. I haven't even used the first quart of it. So that's how I clean, and I just use I just grab a paper towel, and we'll get the board cleaned off and get ready to go. And I like the fact in these, these are nice fat traces, and helps with assembly. I can't talk and move my hands at the same time. You think I would be able to? I'm half Italian, but maybe I can only move one hand at a time while I'm talking. Let's finish getting this. And this needs a little more elbow grease on it in this corner. Make sure it's squeaky clean. All right. Nice and shiny. No fingerprints. Yeah. All right. That looks clean to me. Put the lid back on. Oh, and then after you clean it, only handle your board by the edges. So let's put this in the correct hope the focus is better than the previous two episodes. I spent about an hour trying to figure out how to how to get this camera to focus. All right. Okay, so we're ready. We are ready to get started. So without assembly instructions, I'm going to start with the stacked layered approach, like I mentioned. I don't know if that's a real thing or not. It's just something I learned over the years as a electronics technician, building prototypes and equipment for the Navy and the Air Force. I would generally get a box of parts, a schematic, and from an engineer, and I would build the first few prototypes of. It was usually a communication something, a modem or some kind of radio or interface device, some modems. Gosh, can't remember all the stuff that I got to build. I got to do this all the time and got paid. So now I work in IT, which is just as much exciting. But man does not live by software alone. Got to work on some hardware. Okay. I think the reason why it's dark in here is I don't have all my lights on. All right. So what I like to do is right reading, what I call right reading assembly. So that's where I start on the left side of the board and I work my way across to the right. And all the components, the resistors, will be also what's called right reading. So this one is a 2.2K resistor. I think I got that right. Yes, 2.2K. My memory isn't what it used to be. And I like it so it reads, when I'm looking down at the board, I want to be able to read the color code from left to right. The gold band means 5%. Right, so red is 2, another 2, 22, and 2 zeros, 2200 ohms or 2.2 kilovolts, kilo ohms, which will be written out as 2K2 on some schematics, and that seems to be getting to be the standard for that. So we install everything so you can read the part numbers left to right on the board, and you're assembling your board from left to right. So the first resistor I see here is R2. So we'll start with R2, I see R3, and we'll just work our way slowly across the board, getting things installed. So I've already printed out the components list, and I need to figure out the value of R2. So I do that by searching the parts list. So here's the board layout, the schematic, and interconnections and things for how it goes into the amplifier, how it's going to be all wired up in the amplifier. So I search for R2. Yeah, lots of, okay. Don't give me that. There we are. Well, that's capacitors. So we'll start with R2. R21. R2 is a 447K resistor. So then I just go through my pile. Oops, wrong one. So then I go through my pile, look for, right there. And this is the reason why you want to organize your parts. You can find things a whole lot easier when you're doing your assembly. Let's put it back. So I use this little device. It's like a little pair of calipers in a way, but it helps you bend your leads nicely so the part fits in the hole. And you just take the sharp ends and put it in the hole like so. Let me move this in the middle. Just like this. Am I good? Yeah, looks like I'm good. Tighten it down a bit. And then put the part in there like so. And bend your leads so they make a nice, they're formed nicely. So when parts are being installed vertically, we're going to use, you want to read it from top to bottom just like you would a book. So the part here is yellow, violet, and red with the gold band for the tolerance, which is 5%. I'm going to install it this way on the board. You see how it fit real nice and snug to it. And on the other side, you can't see, I'm going to just fan out the leads a little bit. So when I turn the board over to solder it, parts don't fall out. So the next one I see, oh, we got a couple, R26, R1, R26, R1, R3. Let's do R3. Let's see what R3 looks like. R3 is 470 ohm. That's what the R stands for right there. Just means ohm. So going into the little pile here, I know I have 470. I saw it last night. 470. R3 is right there. We can see that the spacing is the same. So we'll slap the little part in there. Make sure everything's lined up nicely. Like so. And we need to read it left to right. So it's inserted. A little hard to tell in this camera, but that is correct. So it goes yellow, violet, and red, and then you might be able to see the, not really, but there's a gold thing in here. Let me tidy up the focus real quick. Okay, that's a little better. All right, let's double check that. No, that's fine. It's fine. So let's see the next one. What's R26? So we'll find R26. R26 is a 10K. Find it in the, oops. Ah, come on, turkey. There we go. Gotta be able to call yourself names sometimes. Pull out our 10K. Let's see, is it R26? Is it the same? It sure is, so we're good. Bend your leads around, nice. Make sure they're not like that, but straighten them out, make sure they're aligned so the leads are in line with each other. And it goes here. So I like to, when I'm doing assembly work like this, I just do a bunch of parts and then flip the board over and do all my soldering all at once. It just makes life easier. You don't have to keep flipping things around. Okay, what's the next one we're seeing? R1. So let's take a look at R1. R1 is 270 ohms. $270 ohms. Oops. Turkey. I think I'm gonna move that up. There we go. 270 ohms. So when I'm sitting in my easy chair figuring out what the values are, I write them on the little tape, so that way you can see what they are. So we're on R1. Same size. I think we'll find this to be true for a lot of these little quarter-watt resistors. And we make sure it's right reading. So usually the gold or the tolerance band is easier to see sometimes than the actual color bands. But I've noticed for some reason something strange is going on with my eyes now that I'm a little bit north of 50 that I don't know, does everyone else need brighter lights and magnification? You know, I'm asking for a friend. I really don't know. But anyways, let's see what's next. We can do either R27 and R6. They're all in a line. So I like, left to right, work left to right, top to bottom. And I'm sorry, R27 is next. It's right there. The silk screen they're really close. So pay close attention to your board. Because sometimes the parts designator can be a little ways off from the actual part. I've seen them as far away as like this, and you kind of have to figure it out. But be methodical, and I'm not going to be flipping to the manual anymore. So I got, we're doing R27. R27 is another 10K, which I just had out. 7's another 10K. Probably using the same footprint it is. All right, nice and neat. Don't forget to flare the leads out on the other side. R6. R6. R6 is a 22K. 27, 22K. Take the lead out of the tape. Same footprint. It's always good to check a little, just to make sure. Sometimes they have to stretch things out a little bit to get the traces correct. Let go. 6. Okay. Next, go back to the top of the board. I need to add a second monitor. R23. Do it this way. That's too small. Hold on, I'm adjusting my windows here. Oops. R23 is another 10K. Read top to bottom. And our next resistor is going to be R22, which also happens to be a 10K. I think I'll just leave this one out. Yep, dropped it. Left to right. Okay, it looks like the next one coming up is R5. R5 is not 10K. R5 is 2.7K. 2.7K. Left to right on this one. Okay, now we drop down to R4. R4 is 39K. 15, 22, 7, 33, 39. All right, I think that's enough to time to flip it over and do some soldering. That one's really loose. loose for some. That one's really loose for some reason. Okay. Be careful when you're doing this. Try not to touch the traces with your fingers so you don't get oil transfer. Solder doesn't stick to that. Okay, pull out a piece of capacitor solder I've had for, I don't know, 20 years. 0.025 is fine for this. That's the diameter of the this solder. So we'll make sure you are square. I got to tighten the board a little bit, it's skating around on me. And then we just go through, and it's okay if the solder flows on around the pads a little bit. That won't hurt anything. It means it's well tinned, it's a well designed board, well built. There you go. Sometimes you gotta hold your tongue just right. And we'll go through. No, that's connected together. I thought I just soldered a bridge. Keep your tip clean. You notice it was getting a little black on the end. That's from the solder, the rosin in the solder. And after a while, the heat gets to it and it starts to burn off. So you want to keep your tip clean. Yes, I know I need a fume extractor. Got plans for one. It's made out of an old microwave blower motor. I don't think I'll live stream that. Matter of fact, I can't live stream building that because I have to do that outside and I don't have a way to stream from my outdoor workbench. Okay, is that everything? Oh, yeah, looks like it. Well, that one doesn't look too good. Let's see what Mark Scope's got to say. Yeah, I'm on that one right there. No, so you see that? Not enough solder on the joint. It feels good, but it's not. You can see the green in the middle. So there wasn't enough solder on the pad and the lead of that resistor. One that is done correctly would look like that. Okay, it's nicely filled in. It's shiny. It didn't short to the next trace, create a bridge is what it's called, or the next pad next to it. It all stayed put. So that's one. I'll just tidy up the one that I missed. And I think I might be switching solder sizes here in a minute. I might be going to my next larger size. Just some of these holes are too large for the small stuff. All right, that's better. So yes, I have different size solder for different types of soldering. So let's use the scope. So the one on the left is a 0.025, and the one on the right is 0.032. 0.062. 0.062. So, how did that happen? Little off-screen shenanigans going on right now. There we go. We'll just set it in my pocket. That'll work. So yeah, or 16 gauge solder. That's the fat one. And that's the thin one. So sometimes in this case, when I was soldering some of these that had the lead was very tiny compared to the size of the through hole, it was taking a lot. You have to feed a lot more solder into it. So if you have a slightly larger one on hand, you can use that instead, and that's what I'm going to do here. Now you just trim off the little leads, and I use something that is designed for just this purpose, a lead cutter. And the reason why is, and I will demonstrate this on the soldering tutorial, is that these style cutters, when they cut something, they actually mush out a little bit on the end of the lead. So you trim it, and it's going to make it mushroom out a little bit. Now in this case, with the larger through holes, it's not a problem. But in some cases where the through holes are very tiny, very small, and a component is soldered, it's soldered in there, then cut with a pair of regular diagonal cutters like that, it can mushroom the lead out so much that when you need to replace that component and unsolder things, it'll get stuck in the hole. You won't be able to pull it through. And if it's a plated through hole, it's a double-sided board or a multi-layer board. If it's a plated through hole, it could actually pull the through hole out. If you're on a double-sided board, that's not such a big deal. That just means you have to solder the lead on both the top and the bottom of the board. If you're in a multi-layer board, you're pretty much sunk. Because inside the multiple layers, you don't know what's connected to that through hole in the center of the board. So your board is pretty much ruined. You can give it a try. Try soldering a bunch on there. The old saying, the bigger the blob, the better the job, and see if you get lucky enough to fill that through hole with enough solder to make all those connections through the board, but I kind of doubt you'd be able to do that. Don't let your parts fly around. When you cut leads and things, I keep an old tuna fish tin handy and I throw my parts in. I don't like to use like a styrofoam cup or something because sometimes the parts are hot. And just throw it in here and you just snip them off. Oh, I missed one. See that? Right here, I missed a joint. All right. Get the fat boy solder out here. Yeah, that's what we'll use. Okay. Everybody stayed in place. Okay, let's move on. So the next one is, let me put some solder on my iron tip. So when I'm soldering and the tip's is going to sit in the holder for a while, I put a little on each side. I put just a little bit of solder on it and let it sit in there in the holder, and that way it'll stop the oxidation of your tip. It'll help keep your tip lasting longer. Okay, so we have, it looks like R19 is next. R11 is next. So what's R11? R11 is an 82K. So there's 39, 68, 82. Okay, R19 is oh, 1 meg. I happen to have one of those, or 10 actually. I gotta stop bumping things. Sit still. Those R19. Right here. Right reading, top to bottom. R7 is next. R7 is what? A meter shunt. Okay, I'm not going to worry about that one right now because I don't have the meters yet, so I can't determine what value is going to go in that slot, in that. in here, let's see, we've got up at the top R21. R21. 470 ohm. What are you doing? My cat's here visiting. Yeah, you know you don't belong in here. R21. Oh, at the top. And we slide down here to R20. $100K. There. 100K. And sliding down the board again. We're looking at R9. R9. R9 is 27K. Let me check my notes if that's right for me. Yes. $27K. Here we go. So this would be top to bottom. And we have R7. Oh, which is a 22K. So you see this kind of moves along pretty good here. Building, once you're organized, and I think that's the key point, is that you have all your parts organized in an easy to find fashion. And maybe my approach is not your approach, but try and find a way to have everything organized before you get started. And it will save you a lot of time and frustration, which can be huge. So R10 is a larger one, which is going to be, let me see here. R10 is 100 ohm. Nope, sorry. Come on, just R10. Oops. Helps if I put the R in front of it. Oh, come on. R10 is 150K 1 watt. So that's from the DigiKey side of the house. 100K 2 watt. Trimmer. says 1 watt, right? Yeah. Oh, got it. 150K, 1 watt, right here. All right. So, R10. So when I purchase parts from like DigiKey or Mauser, and I'm going through the bill of materials, what's called a BOM, which lists all the components. That's well, it's hard to see, but let me spread this back out. This is called a components list or a bill of materials. And when I'm ordering parts, what I do is, of course, find the one that I need. So I needed it. R10 is 150K, 1 watt, 5% axial resistor. And you can see it right here. So this is DigiKey's part number. At the very top, this is the date I ordered it. This is manufacturer's part number, and then what I purchased, the 150K ohm, 1 watt, 5%. Almost all electronics vendors have what's called a customer reference field, and inside that field, I put what resistor this belongs to. So for this schematic, it's for R10. It makes it so much easier when you're looking through your components. So when you find your 150K, you have your reference of R10, and it helps on your organization. And I don't know why they put 2 stickers on the other side, but that's what they do. So since this is a 1 watt resistor, it's going to be lifted off the board just a little bit, because now you're starting to get now you're starting to having to dissipate a little more heat. But kind of interesting, the 1 watt isn't much larger than the 1/4 watt I just put in. Really close. I would get that wouldn't I'd be confused in this case to determine which one's a 1/4 and which one's 1. Now, of course, as soon as you power it on and start using it, you will know which one's the 1/4 watt and which one is the 1 watt, because the 1/4 watt would probably start smoking after a period of time. And that's, everybody thinks it's electrons that do the work. In electronics, it's not. It's actually smoke, because it's what gets released when you're overloading a part. So anyways, that's my story, and I'm sticking to it. Okay, so now I got to adjust our tool here, my caliper, resistor calipers. And now it's you can tell it's a little wider. The resistor's a little wider than the actual through holes. So I just try my best to center it and then form the leads nicely. Put that in there. It's right reading. Remember, tolerance on the right when when parts are horizontal or resistors are horizontal, and tolerance band on the bottom when it's vertical. Let's see what else we have here. looks like R29 is going to be our next victim. So R29 is what? R29 is you guessed it, 10K. Now it needs to be, calipers need to be adjusted back. Slide down some more. Nothing there. R9, R8. So what is R8? 470K, 3/4 watt. I'm sure I bought a 1. I'm not sure I bought a 3/4 watt. That's kind of... Well, let's go find it. That came from DigiKey. $470 trimmer that goes in the back. Don't need trimmers up front. I'm looking for R8, R13, R105. Let's see, R21, R110. $470K. Yeah, I bought a 1 watt. Yep, it's all right. Okay. I didn't think I'd purchase a 3/4 watt resistor. I can't say I've ever heard of one. And when you're done with these little baggies, keep them. They're good for storing your own parts. When you buy, I buy things in bulk when I can. And so I went, like I showed earlier in the live stream, that I bought a huge package of 610 resistors in a package. And sometimes a good place to get lots of bulk resistors and capacitors is every so often Electronics Goldmine. They will give you like an 84 square inch box full of capacitors and resistors and things like that. So that's the time to buy if you don't mind spending some time identifying parts and getting them organized. When you do that, of course, you have all your parts handy. And when you get a project like this one, where you have to go through and order your parts, you can see what you have in your stash already and help cut down on the costs of building your project. Now the question is that right? Yeah, it's not going to focus in. So let's take a look. I believe it's correct. But let's take a look. Now it's going to be backwards in here. Yeah, so I have it right. Right now the board's backwards. These little USB microscope are $20. And if you're at an age where it's difficult to see markings on parts, inspection, it's good for inspection. I highly recommend you invest in one. I know it means having a computer at the bench. Maybe you can find an old laptop. It doesn't have to be anything high powered to do this. Just enough to run the software and the video software. And you can see it, you know, on a 15-inch diagonal screen or whatever. I've got a 27, but I see the same thing on the screen as you do. So let's return this to its original focus. Those silver lines is actually drawn from my 0.7-inch mechanical pencil, and it looks huge in there. And I had to do that so I needed a frame where I could put the part in and it would show up on the screen nicely. Okay. So we're up to the top again. R24. R24. We'll do both R24 and R25. Oops. Oh, look at that, 10K. R25 is 10K too. All right. Again, top to bottom. And 25 we'll just knock out right now because it's right next door and I got the part out. All right, so we move back down and I don't see anything else. Go back to the top. We've got R18. Oh, look at that. It is not a 10K. What number was that? R18. $220 ohm, quarter watt. Okay, I think that's enough. We'll flip it over and solder those down. Nothing. Okay, so that 1 watt, we need a little off the board. So what I'm going to do is so when you need resistors off the board, what I do is hold on to the height that I want it, That sounds good enough. And then bend the leads on the back to support at that height. So a little crooked. So when you flip the board over, gravity will put it in place and you can solder it. Same with this one. We'll give it a little lift off the board. And now we solder. Some people pronounce the L in solder. Some people don't. I don't. I don't know why. I just don't. So you see the fatter solder is doing a much better job on these parts that have a larger through hole. Gets black gunk on it, you clean it off. Oh, okay, hold on, my board's skating here. It's skating around. Where was I? Oh, on this one. And you work your way. I like to work my way from top to bottom. And top to bottom, left to right. It's getting a little too small. I missed some over here. Oh. Getting dirty again. Keep it clean. I wet my sponge. I do use a sponge. I wet it. I only use distilled water on it. Spend 99 cents for a gallon. It'll last you practically a lifetime. And again, it stops the minerals that are in regular water from fouling up your tip. Okay, almost done here. See, is that everything? I think I got another open hole right here. Go back in and reheat that one up a bit. Gotta be careful, because that's a tight one. Got other through holes right next to it, and it'd be real easy to fill it in. Okay. That looks good. Oh, what temperature do I use my soldering iron at? I use it wide open, 850 degrees Fahrenheit. And I adjust my contact time to suit what I'm soldering. Get all the whiskers cut off here. You know, I should have checked it before I did this. Now that I think about it, is everything good? Yeah, resistors are off the board. Some of these are a little off the board too, but I can fix those. Okay. There we go. Try and stop that board from skating around. I don't know why I did that. Okay. Let's see. You know, I'm just gonna leave those alone. I think they look fine. These are off the board a little bit for spooling. Okay. We are almost done with resistors. Put some solder on the tip here. It's going to sit a while. All right. So we're coming up. What's next here? Looks like R15. Yeah, R15 is a what? 47 ohm. Make sure that's what I need. No, my calculations for the project showed an 82. Okay. 47. 56. 82. Here we are. R15. Okay, so you see, even though it's a quarter watt, R15. Oh, sorry, it's a 1 watt. No. There you go. That would have, as soon as I probably powered it on and started using it, it would give up smoke. I have a 1 watt that goes in there. Let me put this back in the tape. Good enough. 2. Yeah, right there. An 82 ohm plus, yes, 82 ohm 1 watt. So 82 ohm 1 watt. I'm sure the employees of DigiKey finding just one, cutting off just one resistor on a huge tape reel. Probably drives him a little batty. So we were on R15. Come on, stop skating around, boy. You're just being impossible today. I think it's because the board's a little too thin for this holder. Oh, look at that. Someone's at my front door. Go check it out, Ben. Go find him. Ben's the cat. And his brother Jerry's around here somewhere. Thanks for the names to a friend of mine, longtime Navy, WD8 OSU. Thought of the names for our two cats. So, again, you put those just so it's in the center. Form the leads. Gold stripe on the bottom, the tolerance on the bottom. And in we go. So I also want that one a little bit off the board. Like that. A little bit of clearance. What's the clearance, Clarence? If you remember airplane. Okay, so then we got R16 is next. So 1.5K, 1.2, 1.5. Gotta change the calipers to match. Gold tolerance on the bottom. Oops, I bent my leads here. That's upside down. Yeah, come on. There we go. Perfect. Beauty. R28 is next. R28. Okay, hold on here. I gotta read this again. It looks like I didn't buy enough 1 watt 82 ohm resistors. I needed 2 of them. Let me look at the, yep, quantity 1. Bummer. Okay, I don't have that. I don't have the rating of the 1 watt rating on hand. All right. So when that happens, just make a note. Just make a note of it. Come back to it later. Okay, so R17 is next. Another meter shunt, so we're not going to worry about that one. Maybe I said that before. And it looks like R13 is the only one that's left. And we got almost all the resistors done for this. All right. What is R13? It's a big one. R13. A 3-watt 10K. And it's used for receive standby voltage. Okay. 10K 3-watt. $10K 3-watt R13. Okay, this one will definitely have to be off the board. So that's a 3-watt compared to a 1-watt. On the large side. So that'll be lifted off the board. At least one diameter. I like to do it at least one diameter, resistor diameter, off the board. Now these bands are a lot easier to see. Okay, hold on. That doesn't fit in the hole. Ah, there it goes. All right. Okay. Clean the tip again. The larger solder has more flux in it than the skinnier ones. Probably pretty obvious. Here we go. So soldering, notice it took a little longer on these pads due to the size of the wire for the resistor and the mass of the trace, how thick it is, and so that all draws heat away from your tip and it requires you to hold on to it longer against the part. So this is a chiseled tip. Yeah, let's put it under the microscope. Maybe I won't, hopefully it just won't melt it. So take a look at the tip. So the tip is chiseled on both sides. And that's the technique I use to not overheat the joint. I run the soldering station as hot as it can go. It's 850 degrees Fahrenheit. And then my contact time, the technical term is called dwell time, on the pad depends upon what I'm soldering. So these fine parts with small pads and a little bit of trace, I don't leave it on as long because it doesn't take as long to heat up. So that's technical terms called dwell time. Maybe I think that needs more solder. I think I just repeated myself, but not the first time. So you can see it's taking a little bit longer to heat that up. And when I'm soldering on finer parts, I use this side of the chisel, the side of it, because it doesn't have a large surface area. When I'm soldering that 3-watt one down, I use the fat side. So that way more heat can transfer into the lead and the trace. So I hold it for a little bit, and then you see how nicely it flowed. There you go, nice and shiny. And we'll go over more details on that during your first kit build episode. Second Saturday of December. So let's get these trimmed off here. And again, this is kind of a more advanced. You really can't call it a kit because typically kit comes with all the parts ready to go. This was a little more involved because I had to go through the bill of materials and order all the parts myself. And that could be a nice episode itself, showing you how to order parts. So you can see the higher wattage resistors are off. This is off nicely for dissipation, so it could get a tad warm during normal operation, and that's what you want. And you can tell on projects that needed them, but they didn't allow the air circulation. It's because around the let me see if my filter board from the old from the basket case amplifier shows some, you can see on the circuit board where the previous bleeder resistors were down, snuggled to the board, and you can kind of tell that it's brown, has a light brown to it. Yeah, that's probably the best one. Yeah, you can kind of see it more through the board on the other side. This light brown, I mean, they got hot enough that they started to cook the board. Okay, and no, I haven't tested that yet. I was going to last Saturday. My wife was out with her friends playing bunco. My son was at work, and I was getting all ready to test. And I'm like, "You're an idiot." I was an idiot because I was working with high voltage components, and no one was home. So, yeah, I got that life insurance, but definitely don't want to do this when no one's home. High voltage work when no one else is home. Let your significant other know that you're doing this kind of work, and if my wife happens to hear a thud in the garage with no scream, that she needs to come down immediately. A high voltage shock like that, you don't have time to react to anything, and you won't feel anything. You'll just be on the floor, hopefully not dead, but it's a possibility. So be careful with that. Still finishing this morning's coffee. Okay, so we got this done, so what's next? The resistors are as far as I can go. So the next component I'm going to work on is some of the capacitors. Actually, I can put the diodes in there too. Yeah, those will go to the board. There aren't, it doesn't look like there's too many diodes. There's one there. There's one here. 2, 3, 4, 5, 6. Yeah, there's quite a few. So to demonstrate the stacked building approach, say for example, I put the relays in. Let me find those relays. I'm not exactly sure where they are. That's all discrete. I think I left it in the box. Let me go get it. Things might get a little staticky for the moment. I head over there. Maybe not. No, they were in the garage. They're actually right on my bench, right in front of me. Gosh. Locked. Okay. Yeah, here we go. Some of the mechanical components I don't need until I get to that portion of the build. I have to build the chassis and all that, which I might get started on this week. I am off all week. So the stack build process, here's the relays. I don't know if these are the correct one for this slot, for this board. I think so. The other one doesn't have any. So if you have taller components, rock that in there. There we go. So when you have taller components already installed, it can be difficult to get to the lower components that are closer to the board, especially maybe like this diode right there. It would be hard, a little difficult to get in there to get that into the on the board. So by building in layers, as the components get a little taller, it'll help. It really makes the build go smoother and doesn't lock you or make it more difficult to put components on the board. But there are times where you can't do the stacked build way of building. If you have a kit that comes with instructions, of course you follow those instructions. Or if you're building it on the power supply, you're starting with the power supply first, all the power rails and get all that working, then you may not follow the stack build process. So we got diodes in here. So what's D13? 1N4001. And it looks like I bought a boatload of them. All right. Capacitors. I think, are these diodes? Bridge rectifier. Yeah, this is the diode section. Yeah, okay. Senior 12 volt. 1N4007. Bridge rectifier. 1N4001. All right. All right, a whole bunch of them. D13. Come on. Now these videos I don't post-edit. I don't go over and, you know, if I misspoke or something like that, I don't go back and fix things. So the band on the diode's cathode, and you want to match the silk screen to the cathodes on the top on a vertical diode. So these are a little stiffer. What other diodes down here? It looks, oops, sorry about that. D1, oh, there's a bunch of them, D4. Okay, so D1 is a 15-volt Zener. Did I see that? I think I saw that in here, I hope. 12 volt. Right here, 15-volt Zener. Zener diode, 500 milliwatt, 15 volt. Back in the diode section. So this big tray I showed earlier is actually broken into sections. So I've got a divider for capacitors, and capacitors are all up front here in front of it. Resistors are this part, discrete components are in here, integrated circuits are on the end. So I know the general area to look for parts. Again, the organization helps with the building process. It helps alleviate mistakes, but you still make some anyways. Make them from time to time, and it's no big deal. So the diode's a little smaller than the footprint, so we just center it best we can. So what's D2? D2, oh, it's also a 15-volt Zener. All right, make sure the cathode again goes just like it shows on the silk screen. Right here. So the band right here matches the band on the silk screen. Okay, back to the top. D12. D12 is another 1 in 4001. Oh, I forgot to mention also the part number. It's a little hard on these because the part number wraps around the diode. But for something like this, I try and put the part number up so it can be read. You don't necessarily have to. So I was about to put that in backwards so you can see the cathode is on this one, is on the bottom side instead of the top like D13 was. All right, okay. So here's another example of stack building. Look at this area right here. If you put the transistor in first, trying to get these resistors in would be a lot more challenging. You'd be bending the transistor back and forth, and that's not good on the leads. You don't want to do that. Once they're soldered into the board, you don't want to be bending them all over the place. It's okay to do a one-time straightening, but you keep bending them back and forth, you're going to break a lead. So don't do that. What's D3? A 4148 diode. Oh, Let's find that one. Zener. 4007, bridge rectifier. What else is in here? 4148, general purpose. 10, about 10. Grab one. D3 is another one that faces down, the cathode's down. So you want to make sure this is really resistors. Yeah, if you put them in so they're not reading left to right, they will still function. You put diodes in the wrong direction, nothing's gonna work. Oh, it's on D3. D3. So pay attention. Be methodical. Go slow. Okay, D3's in, so we see D4. D4 is in there, and D4 is also 1N 4148. Again, cathode, band. What time is it? 12:30. Ooh, 2 hours. Holy smokes. It's going to be a long one. Because I still want to get all the resistors in. Capacitors. That's what I meant. D6, D7. D6 is a 12-volt Zener. Go through the parts. 0.7, 12 volt. Here we go. Got to keep it in the big. No, I don't. One end. It's on D1. No. D6 and 7. That's what I was doing. D6 is a 12 volt. 12-volt Zener. Here's a 12-volt Zener. It looks just like the other diodes. This is where, again, I can't stress it enough, being organized. Because you can't tell just by looking at it what diode's what, just by the board. So you want to keep everything, again, organized so you can cut down on mistakes. So I was on D6. All right, D6, yes. Okay, D6. D7 is a D7 is an 82-volt 3-watt Zener. Interesting. Where's my pen? $82-volt Zener. Boy, that's an odd one. $56-volt. Rectifier, 56-volt. I didn't order it. No, I said I did. A 2-volt 3-watt. Let me check the main box. Sorry, folks. It's going to take a little bit. I supposedly have says I ordered it. So where is it? Well, it looks like I didn't get it. Opto isolator, op amp, single timer. Okay, shoot. hold on. No, bridge rectifier. All right. Okay, well, I don't have that one. Shoot. I'll double check my parts later. I'm not going to wait up on this one. All right, let's see. Back on the board, we've got, so D7's going to wait. D11. D11 is 1 in 4148. Okay. I'm just going to leave this little pouch out. We're going to be using quite a few of those. That's correct. The band and the silk screen match. That's what you want. Paying attention to these little details, though, that's what gives you better odds of having your project work correctly the first time. Okay. Excuse me. Do you have any more diodes? Oh, we have D5. D5. What's D5? 1 in 4148. No. D. Yes, D540. D5 right there. That band is down because the silk screen says so. Okay. So over here it looks like we have just these two, D14, 15, and 9 and 10. 14 and 15 are 1 in 4001s, and 9 and 10 are also 4001s. Okay. D14 and 15. 1 in 4001. 1 in 4001. Okay, these are actually, I can't fit it in the caliper, so these are real close to the case, so I'll just use smooth jawed needle nose pliers. Don't use the ones that have the little serrations on it, because it will cut into the lead after you bend it and leave little stress marks. There we go. D14, same thing, and then we'll be able to solder all these down. We have a bridge rectifier we could put in. Oh, there's D8. D8 I missed. We'll have to check that one out too. Okay, so it didn't quite lay flat, so push up on the underside and just wiggle it down until you get it to the right spot, and then you're good. D10. Actually, I need to double check that one. Pretty sure I got it right. Yeah, okay, they're both facing up. Kind of straighten it out so it slides through the through hole a little better. And yeah, pay attention, these two are opposite, not like 14 and 15. There we go. Alright. These I can use the calipers on, they'll make it a little better. Okay, D8. D8. D8 is a 1N5337B. Oh, the 4.7 volt one. I know where that is. It's right here. So that one's going to barely fit into the into the through holes here. Yeah. Okay. Yeah. What's the rating on that one? Oh, that's a 5 watt. Okay. So we're going to want that off the board for cooling purposes. That's a 5 watt Zener, so it's going to be carrying some current. I think it's time to flip it over and do some soldering. question is this one up here a solder bridge? Let's see real quick. I don't remember. No, it's not. Just the way it should be. Okay, we'll run through these real quick. This one will take a while. It's got more copper and fatter lead to, so you want to hold that on. Give you a longer dwell time. Same with this one. Okay. What others do I have sticking out? All right, everything's looking good. Yeah, this is going to be a beefy one right here. Almost there. Almost there. Okay. There's one I cut a little too close, so I'll just warm that joint up a little bit. There we go. Okay, that's the diodes. Now, board's coming together. Okay, bridge rectifier 1. We can put that in there. Bridge rectifier 1 is a 2 amp volt. Is that the one up front? Yes. Okay, so this one, the head on this is a little different. Sometimes they're square, sometimes round, sometimes they're a single inline package, a SIP. These are round. And on here, let's move this in the middle so you can see the plus sign here and the plus sign there. I'm sorry, that's for the capacitor. Where am I? Okay, right here. BR1, sorry about that. The plus sign here, and the little squiggly marks. That's the AC, where the AC voltage comes in. This is the bridge rectifier circuit. And this was the 4.7 volt Zener, and they're going to make a power supply for probably U3 and some other components in this area. This also needs to be off the board a little bit, so we'll go ahead and get that in there. Like so. We're going to leave it off the board. That looks like a decent amount. Yeah, just make sure it's parallel to the board. We'll flip it over. Get some heat. Double check that it shifted a little bit. Okay, that's fine. I'll go back around and get the other 4. All right. Still sliding around. It's all right. We're almost done for today. Okay. That is the end of the... No, there's 2 more diodes up here. D17 and 18. D17 and... Maybe that's 16. 14, 15, 16, 17. That's what I'm going with. D1617 or 4000, the 4001s. Those are bent right at the body. All right, is that it? Excuse me. I do not see any more diodes, so let's get these soldered down. Use a little more solder on that one. Okay, let those cool. Still a little hot. Okay. Let me look at those joints real quick. Yeah, that looks fine. Okay. Okay, that's it for diodes. What's next is capacitors. Okay, so for the silk screen on capacitors, these are regular disc type. These types of capacitors are electrolytics. They have a little plus sign for polarity, and that must be obeyed. If you don't, they will explode as soon as you apply power. And they smell like burnt Cheerios. So let's get the capacitors going, starting from the left. We've got C1. Let me find C1. What are you doing? So I want just C1. Everything starts with a 1. Can't be. Okay. C1 is a 10 microfarad, 35 volt. Capacitors are C11. Yeah, I'm not as organized as I should have been. .01 microfarad. Not that one. C14, C10. Got it. Now capacitors have different markings on them. This is a 10 microfarad cap, and these disc caps are not polarized. But still, what I like to do is install them so the part number can be viewed from the bottom of the board. So the next one we have is C2. Oh, I'm sorry, we missed one. C1. Wait a minute. C3. I just did C1. C1's a 10 microfarad, 35 volt. Okay, I royally screwed that one up. I don't know what C3 is. C3 is 0.1 microfarad, which I have right here. Okay, I'm looking for a electrolytic. .10 microfarad. C1, C2, 35 volt. Yep. Okay. So these are also marked. They come like this. So I don't need those full length leads, so I cut them off. And they're marked like this. You see that big fat minus sign? Yep, it has to go into the minus through hole. And here's this one's a little chopped off, but 10 microfarad, 35 volt. Okay, so make sure there's the plus sign. C3 is a 0.1 microfarad. 0.1 microfarad. That's not it. Probably this one. 33 puff. 0.4 film. Oh gosh. Aha. I bought C3, right? Yes, okay. So these even have smaller markings on them. That side is the value, 104, so it's 10 microfarad. So it's a 1 0 followed by 4 zeros. And then on the other side, K1M. I think that's the rating of it, which happens to be 100 volt Z5U. Temperature. That has to do with the temperature coefficient of the capacitor. So when capacitors warm up, they tend to change their change their value one way or the other. And you want to, and that becomes important, especially in oscillator circuits and things. You want to have the right capacitors there. Now, that would be an interesting video would be to do such a thing. Create a little test circuit and warm up a capacitor and watch the capacitance change. So C2, 10 microfarad, 35 volt again. Paying attention to polarity. So it goes in this way. Okay, let's go top of the board again. Where's my little pointer stick? Top of the board again, we got C16, and that's a C16, 13, 14, C16 is another one of the 0.01s. Oh, you just had them. C16. Yeah, all right. Right reading, so the value goes on the left side. Okay, next is, let's see, C16, C6. C6 is a 33 puff picofarad. 33 puff right here. Now these are impossible to read without some kind of magnification. You can't see that at all with my glasses. 330. Again, the value on the left side. What's C4? 0.01 microfarad. 0.01. Oh, put that part in the wrong bed. C4. What's C4 again? 0.01 microfarad. Yeah, I should have those. 33. Did I leave? No. I hope it's not another part I didn't order. It looks like that part's missing too. C4, it's a single part. 0.01 microfarad. I'll have to double check. We'll move on. C4, C11, 0.47 microfarad, 100 volt, and I saw that one. C11, 0.47 microfarad, 100 volt. Okay, that's not it. It's just a single part number. 5. C10. C11. Well, that's it. All right. All right, like so. Boy, that's pretty tight on that diode D7 in there, isn't it? Okay, let's do some soldering. Oh, you little bugger, you. Yeah, C6. I didn't bend the lead, so it fell out. Time for another strand of solder. getting dirty. Okay. Got those. Got one here. I missed one at the top. Okay, is that it? Yep, looks like. All right. Oh, take these off. Okay. Almost there. Okay, a couple more caps. C15. I'm looking, there's nothing else down here. C4, oh, C5, C7. What's C5? C5 is a 4700 puff at 63 volts, or I probably got 100. 1 kilovolt, got one at 1 kilovolt. We don't want that one. Ah, 4700 puff right here. Another one on tape. So I can't tell which side the marking's on. It's that one. 47 and 2 zeros. Nothing on the back. So this is C. Oh man, what was I on? C5. All right, so this part's a little wider than the footprint on the board. So these are preformed. We'll just take the form out of it, like so. Yeah, that's better. A little lopsided. Push that back up. Okay. C7 is another 0.1, which I kept aside here. So what I meant by preformed is the leads are bent already. C7 again. Nope, not the K1M. We want this side on the right. here, back to the top, C15. C15 is I think it's an electrolytic. C15 is a 100 microfarad, 50 volt. So it's in my electrolytic pile. C15. Again, in the customer reference, put the part number in it. Makes it easier to find your parts. This one also comes on a long leaded tape. Positive is up here. It's funny, that's the funny thing about electrolytics. They mark the negative lead, but on the circuit board silkscreen, they put down positive lead. Just an observation. All right, what we got left here? C14, right there. C14 is another 0.1. And I'm using 100 volt versions instead of the schematics calling out for, and that's okay. You can always go up to the next highest voltage rating or be safe. You just can't go down to the next lower. Then you start letting smoke out of things. Okay, what's C8 is next? C8 is the 1000 volt 4700 puff right here. Now these leads are not going to match. Even though they're formed. Oh, maybe they will. C8. No. They are not. So what we'll do here is actually put the calipers on it. I don't know if these are really called capacitor or calipers or not, but we will set the bend the leads out a little bit. Like so. Put them in here. See if you can get centered. That's where you need a third hand. Okay, that's better. Looks a little how you doing, I guess. But they'll drop right in like that, and that'll be just fine. Let's see what's up here at top. C13 is another 0.1 microfarad, 100 volt. C13, drop that in there. Coming down, we got C12. C12 is a 10 microfarad, 35 volt. Yeah, that's this one. Yep. Oops. Getting a little disorganized here. Okay, then we're down to C10. C10 is a what? C10 There's another 0.01 microfarad 1000 volt, which is yep, C10. Okay. So we can look at the part. A 10 with 3 zeros, which also 10,000 puff is the same as 10,000 picofarads is the same as 10 nanofarads or 0.01 microfarads. And that was C10, which is another one that's going to be stretched out. But that should be fine. Okay, back at the top, C17 is a 2200 microfarad, 16 volt. It's going to be one of the fatter ones. C17. Another thing about electrolytic caps is they also make different lead lengths. Positive is long, negative is shorter. So now you can make sure that you put them in the right spot, in the right polarity, and we got our first, pretty snug. Pretty snug on the board there. See, it really pushes that diode over. Another good reason for the stack building approach. It would be hard to get those diodes in after this bad boy was put in there. So now we come down to C9. C9 is a 0.1 microfarad 1000 volt. My other 1000 volter. Okay, diodes need to go back in place. Volts. C9. C9. Did I order it? I did not. I had to order those from Jameco. I forgot to do that. I've got quite a few actually. Some of the higher voltage ones. Okay. Well, we'll solder this up, and this will be it. Okay, that's a nice solder bridge right there. A little bit of very thin solder wick here. We'll also cover this on your first kit. Episode, how to fix mistakes. Okay. That needs a little more solder on there. This needs a little more solder there. Okay. Off we go. Ouch. That's way over to one side. Oh, no, that's fine. Da-da-da-da. Another one right here. Looks good. Yeah, it looks good. Okay. Put some solder on the end of the tip. So more than likely, we'll be shutting things down here in a couple minutes. And if you happen to make it all the way through this video, which is a little over 3 hours long, I appreciate it. I am planning on more coming up. Be sure to check the website at ka6wke.net/ there's a join I missed /live-stream for the schedule, the upcoming schedule. And direct links to the videos. I'm double checking this isn't a bridge. Or no, okay. Oh, missed the whole part. Where's my other little solder? Okay. All right. That's going to be it for today. Everything came out nice. A couple of parts forgot to order, but that's easy to take care of. So hopefully, like every time, you learn something new. And I appreciate you watching. If you didn't make the live stream, of course, this will be archived on YouTube. And when they're done processing it, I will update web pages and things, and so you can watch this probably at double speed. I think my voice is low enough. You could double the speed of the video and get through it much quicker. So, anyways, 7-3 for now from Southern California. Have a great, if you're in the United States, have a great Thanksgiving, and I will catch you on the first Saturday of December. Take care.